So students, we've been learning a lot about systems of equations. A system isn't just one line, it's two lines. And the solution is where they intersect. So far, we've learned two different ways to solve for systems, for the solution of systems of linear equations. Substitution and graphing. This last way is really fun because it's called elimination. So as you could guess, there are going to be some things that are getting the axe. Let's take a look at these two linear equations. Okay. Now, it appears like graphing would not be the easiest way to solve this system because we'd have to isolate for y in both cases, which would take a couple of steps. We could use substitution. We'd have to isolate for a variable, and then we'd input that into the other equation. But maybe there's an easier way. This way is called elimination. You'll notice that these two equations are stacked on top of one another, with the x's on top of x's, the y's on top of y's, and the constant terms on top of the constant terms. In order for elimination to work, they must be stacked on top of one another just like this. And you'll see why in a moment. If we were to add each of these together, would any of the variables cancel each other out? Well, negative 2x plus 4x would be 2x. Y plus 3y is 4y. And 7 plus 10 is 17. So the x's and the y's, they're both still existing in this third equation we have when we add these together. So that doesn't really work. We want one of the variables to completely eliminate itself. So we do what anyone would do. We wish upon a star. Dear star, I wish that this said negative 4x, because if it said negative 4x, then the negative 4x and the 4x would cancel each other out, and I'd be left with 0. What's that you say? Dreams do come true? All I need to do is just write whatever I want? I can make my dreams come true? Oh, so all I need to do is write negative 4x. Interesting. But, oh, I need to treat everybody the same. You know, I remember that. I have to be fair. Okay, so the star has told me exactly everything that I have to do. To get to negative 4x, what did we multiply this negative 2x by? 2. We multiplied by 2. Negative 2x times 2 is negative 4x. Now, negative 4x plus 4x cancels itself out, so we're in good shape, but we have to be fair. Do it to everybody. If we multiply this by 2, we have to multiply this by 2, and we have to multiply this by 2. Treat everyone fairly. So negative 2x times 2 is negative 4x. 2 times y, well, that's 2y. And 2 times 7, that's 14. Because we were fair and did it to both sides, this is a perfectly legitimate algebraic maneuver. 4x minus 4x is nothing. It cancels itself out. 3y plus 2y is 5y. And 10 plus 14 is 24. Ah, how easy is that? 5y equals 24. Well, that's 5 times y equals 24, so we just have to divide both sides by 5. So y equals 24 fifths. Splendid. Okay, now all we need to do is input this value into either one of these equations, and we'll get the correct answer. Let's input it into this first equation. And the reason I chose this first equation is because y doesn't have a coefficient. So this one will make it slightly easier to solve for x. Let's take a look. Okay. So we take y equals 24 fifths and we input that for y. So now we have negative 2x plus 24 fifths equals 7. This is the same exact equation as this one. The only difference is that we input y as 24 fifths because we know y is 24 fifths. Now we subtract 24 fifths from both sides because we're trying to isolate for x. 24 fifths minus 24 fifths is nothing. Now 7 is the same thing as 7 over 1. So let's get common denominators and multiply the numerator and the denominator by 5. So now we have negative 2x equals 35 fifths minus 24 fifths. All right, 35 fifths minus 24 fifths is 11 fifths. So negative 2x equals 11 over 5. Last step, divide both sides by negative 2. So this is like negative 2 times x, so we need to do the opposite and divide. Divide both sides by negative 2. So x equals 11 divided by 5 divided by negative 2. Well, division and multiplication are opposites. So instead of dividing by negative 2, we can actually multiply by 1 over negative 2. So x equals 11 over negative 10, which is the same thing as negative 11 over 10. So our ordered pair here for the solution of where these two lines intersect is negative 11 tenths and 24 fifths. In summary, in order to solve systems of equations with elimination, simply make your dreams come true. If you want a variable to eliminate itself, make it so. As long as you're fair to the other terms in the equation, you can write anything you want. After those variables eliminate each other, it's very easy to solve for the other variable. Input that variable into either equation, and you will get your answer of where those two lines intersect. Thank you. Have a great day.